Somewhere deep in the Pacific Northwest, a machine the size of a house is climbing a 45-degree slope with a freshly cut tree gripped in its jaws without slipping an inch. Thousands of feet away, steel cables thicker than your wrist are hauling massive logs through the air above mountain ravines no truck could ever reach. These aren't science fiction, they're real. They operate in forests right now, and what they can do will completely shatter your idea of what a machine is capable of. Number 1. The Ponsse Scorpion Giant. Let's kick things off with a machine that, from the moment you lay eyes on it, looks like it came from a different planet. The Ponsse Scorpion Giant is a Finnish-built forestry harvester that represents one of the most sophisticated pieces of terrain-conquering engineering on Earth. Ponsse, a company founded in Vieramäe, Finland in 1970, has spent over 5 decades building machines specifically for the worst conditions forests can throw at operators. The Scorpion Giant is the crown jewel of that effort. Here's what makes it extraordinary. The machine operates on 8 wheels, 4 bogies, which dramatically spreads its weight across the forest floor and reduces ground pressure to a minimum. But the real magic is in the frame. The Scorpion Giant is built around a 3-piece frame connected by rotating joints. The cabin sits in the middle frame, which is hydraulically leveled at all times. The front and rear frames tilt and move with the terrain independently, meaning the operator is always sitting level even when the machine itself is climbing over rocks, crossing ditches, or traversing steep slopes covered in snow. Think about that. While the machine's body is bending and flexing to follow uneven ground, the cab stays completely still. The operator is essentially riding inside a stabilized bubble, and it gets better. The Scorpion Giant features an active leveling and stabilization system that constantly reads the terrain and adjusts in real time. Engineers developed it with 11% more tractive force than the previous Scorpion range, specifically to handle steep slopes, soft ground, and deep snow conditions where other machines would simply get stuck or tip over. The crane on the Scorpion Giant, the C50 Plus, offers a reach of between 8.6 and 11 meters, and it's operated through a system called Ponsse Harvester Active Crane. Instead of controlling individual boom movements, which is mentally exhausting over a long shift, the operator simply points the crane head at the target location, and the machine figures out how to get there automatically. The operator focuses on the tree, the machine handles the geometry. The harvester head, typically the H8 on the Giant, can fell a tree, strip every branch from it, and cut it into pre-programmed lengths in a matter of seconds. All of this is controlled through Ponsse's Opti5G information system, the most advanced forestry computing platform on the market, which tracks every log cut, adjusts feed speeds based on tree diameter, and keeps productivity data in real time. Over 1,200 Scorpion machines have already been built and delivered to more than 25 countries around the world. The Scorpion Giant specifically targets markets in Scandinavia, the United Kingdom, Ireland, France, Germany, and North America, anywhere the forests are dense, the slopes are steep, and the ground is soft. Number 2. The Komatsu 931XC8WD Harvester. The name says it all. The XC in the Komatsu 931XC stands for Extreme Conditions. And that's not just marketing language. Komatsu launched this machine specifically to address the growing demand for harvesters capable of operating in the most challenging terrain conditions. The 931XC is an 8-wheel drive harvester that competes directly with the Ponsse Scorpion in the global market, and the competition between these two machines is intense, precisely because both are built to such a high standard. What sets the 931XC apart is its unique double Komatsu comfort bogie drive system. While other 8-wheel harvesters typically use a stiff rear axle, the 931XC uses a pendulum axle with a bogie system on top. The front bogie has a range of 28 degrees of movement, while the rear bogie covers 22 degrees. The rear pendulum axle itself offers 16 degrees of oscillation. What this means in practical terms is that all 8 wheels are almost always in contact with the ground, even on extremely uneven terrain. More wheels touching the ground means better traction, less slip, and dramatically reduced ground pressure, which is critical for sustainable forestry and for preventing the machine from sinking into soft or wet forest floors. The harvester's transmission system has been specifically optimized for low working speeds. The kind of slow, powerful crawl you need when you're pushing through dense undergrowth or climbing a muddy slope. It delivers a broad power band with high torque backup for exactly those moments when conditions get unexpectedly difficult. The cab on the 931XC also features automatic crane and cab leveling, the same principle as the Forestry Giant, keeping the operator stable while the machine works on slopes. It's equipped with a large front window for excellent visibility, ergonomic seating, automatic climate control, and sound-deadening construction to reduce operator fatigue across long shifts. The 931XC works hand-in-hand with the Komatsu 855E forwarder, which is designed to carry full loads of cut timber out of the same extreme terrain the harvester just worked through. Together, they form a complete cut-to-length system capable of operating in forests that would defeat almost any other harvesting setup. Number 3. The Tigercat L855E Leveling Feller Buncher. If the Komatsu and Ponsse harvesters represent the precision end of extreme forestry, the Tigercat L855E represents raw power engineered for the absolute edge of what's physically possible on a slope. Tigercat is a Canadian manufacturer that has for decades been widely recognized as the global leader in steep-slope conventional ground-based harvesting. The L855E is their leveling feller buncher, a machine designed specifically to operate on terrain so steep that without specialized engineering, any other machine would simply roll over. A feller buncher, for context, is a machine that drives up to a standing tree, grabs it with a massive cutting head, cuts it off at the base in a single movement, and holds it, bunching multiple trees together before placing them on the ground in a neat pile for extraction. It's a fast, high-production approach to clearing timber, and when you put that capability into a machine that can work on 45-degree slopes, you have something truly remarkable. The L855E achieves its slope capability through a hydraulic leveling system built into the undercarriage. As the machine traverses a slope, the leveling system continuously adjusts the cab and upper structure to stay level. The tracked undercarriage provides maximum grip and stability on loose, steep, or rocky ground where wheeled machines cannot safely go. Tigercat's signature ER boom system, where ER stands for extended reach, is fitted to the L855E. This gives the machine tighter tuck when carrying trees, a wider range of movement, and critically, more capability to work below grade, meaning the machine can reach down a slope to grab trees that are lower than its own position. The boom routing also protects the hydraulic hoses that power the felling head, a critical detail when you consider how much abuse these machines absorb on steep rocky terrain. The side-opening engine roof on the L855E is another brilliant engineering detail. When maintenance time comes, which happens often in this kind of work, the entire roof opens to expose the engine from the top and both sides simultaneously, giving technicians a full-service platform to work comfortably and safely, even in remote locations deep in the forest. Number 4. The Tigercat X870D Track Feller Buncher. While the L855E is focused on leveling capability for steep slopes, the Tigercat X870D takes a different approach. This is a high-performance tracked feller buncher built for highly skilled operators who demand machine performance pushed to its absolute limits. The X870D is equipped with closed-loop track drives, which means each track is independently powered by its own closed hydraulic circuit. Closed-loop systems offer faster response, more precise speed control, and better performance compared to open-loop systems. For a machine operating in rugged terrain where split-second adjustments can mean the difference between stability and a rollover, this level of control is essential. The machine is matched with the most demanding final felling applications in the toughest terrain: large timber, steep ground, rocky obstacles. It's the kind of machine that experienced, skilled operators specifically request when the job is in territory that would stop other equipment cold. Number 5. The Ponsse Mammoth Forwarder. Cutting down trees in extreme terrain is only half the battle. Once those trees are processed, someone has to carry them out. That's where the Ponsse Mammoth Forwarder earns its name. Forwarders carry logs entirely off the ground, loaded into a bunk on the rear of the machine, rather than dragging them, which is how skidders work. This off-ground method dramatically reduces soil damage and disturbance to the remaining forest, making forwarders the preferred choice for sustainable forestry. The Mammoth takes this to a new level of scale. The Ponsse Mammoth sits in an entirely new category. 25-ton load carrying capacity. It is fitted with a continuously variable transmission (CVT) system, which means there are no gear changes. The machine smoothly adjusts its power delivery to match whatever the terrain demands, whether that's crawling through deep ruts at low speed or moving efficiently along a forest road with a full load. The K121 loader crane on the Mammoth is purpose-built for the machine's size class, with hydraulics strong enough to swing and stack massive stems that would challenge lighter equipment. The frame structures are built to handle loads that, on lesser machines, would cause structural fatigue over time. Where the Mammoth particularly excels is on sites with long driving distances, where getting logs from the harvest area to the roadside requires serious travel time. The CVT system makes that travel as fuel-efficient as possible, and the machine's suspension is designed to handle rugged forest terrain even when running fully loaded. Number 6. The Skyline Cable Yarder System. Now we move into a completely different category. Not a self-propelled machine in the traditional sense, but a system that achieves something almost none of the wheeled or tracked machines above can: extracting timber from terrain where no machine can physically go at all. Cable yarding, also called skyline logging or tower logging, is one of the most impressive engineering achievements in the entire forestry industry. It is the dominant harvesting method on the steep slopes of the Pacific Northwest of North America, New Zealand, parts of Japan, and the mountainous regions of Central Europe, Austria, Switzerland, Italy, France. Here is how it works. A large motorized yarder, essentially a massive winch system mounted on a truck or crawler, is positioned at the top of a slope on a flat landing area. A tall steel tower, often 30 meters or more, is raised and anchored into place using multiple heavy steel guy lines. Then a main cable, the Skyline, typically around 1.25 inches, about 32 millimeters thick, is strung from the tower down to an anchor point at the far end of the logging area, which may be hundreds or even thousands of feet away. This Skyline holds itself high above the ground. A motorized carriage then rides along the Skyline. When the carriage reaches the logging area, choker cables, short wire ropes, are attached to individual logs or groups of logs. A single grapple yarder can pull in 5 to 10 logs at a time, using separate chokers. When the yarder is activated, the logs are lifted partially or fully off the ground and transported through the air back up to the landing. The critical advantage here is that the logs never drag across the forest floor. On a steep hillside, dragging logs ground level causes severe erosion, damages waterways, destroys the soil structure for future forest growth, and can be extremely dangerous for workers. By lifting the load into the air, cable yarding eliminates most of that damage. Getting the initial Skyline into position across mountainous terrain used to require workers physically carrying and unspooling hundreds of pounds of cable across steep, dangerous ground. That's still done in some operations, but increasingly large drones are being used to carry lightweight synthetic pilot lines across ravines and ridgelines, dramatically improving both safety and efficiency of the rigging process. Modern carriage systems have evolved far beyond simple mechanical devices. Since radio control was first adopted for carriages in the 1960s, the technology has advanced to include automated movement, integrated cameras, geospatial sensors, and increasingly, remote operation systems. Electric carriages have emerged as a product category, particularly in Central European markets where energy efficiency and low mass are priorities. Number 7. The Tigercat X870D Forwarder. Back to self-propelled machines, and this one is built for around-the-clock, high-production operation in the toughest terrain a forwarder is likely to encounter. The Tigercat X870D Forwarder is designed for what the company calls extreme duty cycle applications. 6-wheel drive, combined with a high-capacity clam grapple, gives this machine the ability to transport massive log loads across long distances and across soft terrain that would bog down lighter equipment. Tigercat specifically highlights the X870D's suitability as a base carrier for scarifier attachments, a scarifier being a ground preparation tool that breaks up compacted soil or debris on reforestation sites. This is a demanding, high-impact use of a forwarder, and the X870D is built robustly enough to handle it. Number 8. The John Deere 1270H Rubber-Tired Harvester. John Deere is one of the biggest names in forestry equipment globally, and their 1270H rubber-tired harvester represents the brand's answer to the challenge of combining terrain mobility with high harvesting efficiency. The 1270 hatch operates on rubber tires rather than tracks, which gives it superior speed and mobility on firm forest roads and moderate terrain. For operations in Scandinavia and North America, where much of the harvesting happens on ground that's challenging, but not at the extreme end of the scale, the wheeled approach offers clear productivity advantages. The machine can travel faster between harvest blocks, is easier to transport on public roads, and has a lower operating cost per hour than a tracked machine in suitable conditions. John Deere declared in November 2024 that it would increase manufacture of its forestry equipment at its specialty products plant in Langley, British Columbia, a sign of the growing global demand for high-quality harvesting machines. The company has been ramping up production of its 800 series and 900 series harvester lines to meet that demand. Number 9. The Magni heavy-duty telescopic handler. This is a machine that isn't typically the first thing people think of when they hear forestry equipment, but in challenging terrain operations, it has become indispensable. The Magni range of heavy-duty telescopic handlers, showcased at the APF 2024 Forestry Exhibition in the UK, offers payloads of between 10 and 45 tons. These machines are described as simultaneously functioning as a platform, a crane, and a forklift. Working heights range from 18 to 51 meters, with lifting capacities between 4 and 13 tons. What makes these relevant to extreme terrain forestry is their rough terrain tires and high ground clearance, combined with exceptional cab visibility through panoramic windshields and air conditioning. In steep and irregular forest terrain, being able to precisely lift and place heavy loads at height, whether that's stacking timber, supporting cable yarding operations, or handling large machinery components during maintenance, requires exactly this kind of heavy lifting capability. Number 10. The Rottne F20E forwarder. We close our list with a machine that has earned a nickname in the forestry world, the Swedish Beast. The Rottne F20E forwarder is, by the company's own description, the largest forwarder in the Rottne range, and the sheer numbers behind it explain why it belongs on any list of extreme forestry machines. Rottne Industri AB is a Swedish family-owned company, founded in and named after the small town of Rottne in southern Sweden. The company has been building forestry machines since 1968, when its first product, the legendary Rottne Blondin, rolled out of the factory. That original machine served as the base unit for Rottne's entire lineup of forwarders, harvesters, and dumpers for 2 full decades, from 1968 to 1988. The heritage matters because it explains the engineering philosophy that runs through every Rottne machine built today. Robust, reliable, purpose-built, and designed specifically for conditions that would destroy lesser equipment. The F20E is the current pinnacle of that 60-year lineage. Its headline number is its 20-ton load capacity, one of the largest of any forwarder in production anywhere in the world. That's 20,000 kilograms of timber loaded into the bunk and carried through challenging forest terrain to the roadside. But the truly remarkable specification is what drives that load. The F20E is fitted with a variable hydrostatic transmission that delivers a tractive force of 27 tons, 270 kilonewtons. To put that in perspective, that's more pulling force than many large road construction machines. It means the F20E can haul its maximum load across steep grades, through soft boggy ground, over rocky terrain, and through deep ruts without losing momentum or getting stuck. The engine achieves its maximum torque output at a very low speed, between 1,000 and 1,500 RPM, which is ideal for slow-controlled, high-load forestry work, where spinning an engine at high revs wastes fuel and generates unnecessary heat. The chassis rides on balanced bogies with large wide wheels, which achieve excellent flotation on soft ground. Flotation is the critical measure of how well a machine distributes its weight to avoid sinking, and the F20E's bogie design means it can traverse wet, soft forest floors that would swallow a machine with a narrower footprint. The machine is also fully compatible with bearing and drawing tracks on all wheel pairs, meaning it can be fitted with rubber or steel tracks over all its wheels to further reduce ground pressure and improve grip in the most extreme conditions. For loading and unloading timber, the F20E carries the RK160 crane, Rottne's top-of-the-line loader. The RK160 features a large oil flow system, and critically, the valve package is mounted directly on the crane close to the hydraulic cylinders rather than back on the main chassis. This design shortens the hydraulic circuit, which means the crane responds faster and with more precision. The crane's reach extends up to 10 meters, and its torsionally strong base structure provides high lifting capacity that allows even large diameter stems to be swung quickly into the bunk. The F20E's load bunk itself is available in two configurations. The standard version is wide load, a width-adjustable area with mechanically adjustable load bunks and a hydraulically adjustable headboard. The premium option is Wide Load XL, which adds hydraulic stakes and a fully hydraulic width-adjustable gate. The advantage of these wide configurations is that log loads can be spread horizontally across the bunk rather than stacked vertically, which lowers the machine's center of gravity, improves stability on slopes, and makes loading and unloading faster and smoother. The cab on the F20E follows Rottne's universal cabin strategy. The same cab design is used across all Rottne forwarder models. This is a deliberate choice. It means that an operator who is trained on a smaller Rottne machine can step into the F20E and immediately feel at home with the controls, the display, and the layout. The Comfortline cab suspension system isolates the operator from ground vibration and impact through continuously active hydraulic damping, making what could be a brutally physical day's work across rough terrain significantly more manageable. Sound levels inside the cab are, according to Rottne's specifications, lower than inside a new car, an extraordinary achievement for a 20-ton machine working in extreme terrain. Machine management and data tracking are handled by the Rottne D5 control system, which runs on CAN bus technology and continuously monitors the engine, transmission, hydraulic loader, and key operational parameters. The system integrates with GeoInfo software and optional GPS, which allows the forwarder's computer to receive production data directly from the harvester working in the same area. The forwarding routes are planned, every log stack is given GPS coordinates, and the entire operation is tracked and reported automatically, including time spent loading, unloading, transporting, and on maintenance. What makes the F20E particularly powerful as a piece of extreme terrain equipment is the combination of all these specifications working together. It isn't just large, it isn't just powerful, it is specifically engineered so that its massive capacity doesn't become a liability on difficult ground. The bogies keep it floating, the transmission keeps it moving, the crane keeps loading fast, and the cab keeps the operator productive across long hours in remote locations. If you found this video interesting, you'll want to stick around for our next deep dive into the technology behind autonomous harvesting systems, because the machines you saw today are already being prepared for a future where they operate with minimal human input, deep inside forests that no person needs to enter at all. Drop a comment below telling us which machine impressed you the most. And if you didn't know cable yarding existed before today, welcome to the club. It blew our minds too.